1957. A British linguist named J.R. Firth writes an essay. Buried in the middle, one throwaway line. You shall know a word by the company it keeps. He meant it casually. A guideline for how to figure out what a word means. Look at what other words appear around it. That was the whole point. 50 years later, that one line, turned out to power every NLP system on Earth. Search, translation, LLMs, everything. This is the distributional hypothesis. And it's easy to miss why it's such a big deal. Because it says something really specific. Meaning can be recovered from usage patterns. You don't need dictionaries. You don't need logic. You don't need a semantic ontology. Just count what appears near what. In enough text, that's enough. The whole field of vector semantics rests on Firth's throwaway line. Last video I told you Word2Vec and Glove end up computing basically the same thing. Both compress co-occurrence statistics into a low-dimensional geometry. That was Levy and Goldberg's clue. Today we ask the question underneath. Why should co-occurrence statistics carry meaning at all? Turns out the answer was proposed in 1954, a full decade before I was born, by a Chomsky classmate named Zellig Harris, and restated by Firth in 1957. The puzzle for today. If meaning can be recovered from just word neighborhoods, then a lot of things follow. NLP doesn't need philosophers. Semantics is a statistics problem. But is that actually true? There are obvious counterexamples. Antonyms have similar contexts. Hot and cold appear in the exact same sentences. Why does the hypothesis work anyway? Today's 3 beats. First, the actual history. Harris 1954 and Firth 1957. What they said, what they meant, and who influenced whom. Second, why it's an empirical claim about how humans use language. Not a linguistic universal, not a law of physics. Third, the counterexamples, antonyms, homophones, function words, and why the hypothesis works anyway despite them. Beat 1. Zellig Harris, 1954. Paper titled Distributional Structure. Harris was a structuralist linguist at Penn. Chomsky's advisor, actually. His argument. You can figure out the structure of a language purely by looking at what elements can be substituted for each other in the same contexts. Words that can appear in the same sentence, slots belong to a category. That's distribution. And distribution, he argued, is enough to reconstruct language structure. Firth, 1957. Same idea, better sentence. Firth was a British linguist at SOAS in London. His essay is called A Synopsis of Linguistic Theory, 1930-1955. Buried in it, the famous line, "You shall know a word by the company it keeps." The King James Bible cadence is deliberate. Firth had a flair. His point, the same as Harris, but phrased so beautifully it became a slogan. Slogans travel. That's why we quote Firth and not Harris. Notice the timing. Firth 1957. Harris 1954. And what else was published in 1957? Chomsky's Syntactic Structures, which argued the opposite. Language structure isn't recoverable from surface distribution. You need a mental grammar. Firth and Chomsky were fighting a war in the pages of the same year's journals, and for 50 years, Chomsky was winning the war, right up until the point where the distributional camp built systems that could translate 100 languages and Chomsky's camp couldn't. Beat 2. The distributional hypothesis is an empirical claim, not a linguistic universal, not a law of physics, not a philosophical necessity. It says, in the languages that humans actually use, in the corpora that humans actually produce, words that mean similar things happen to appear in similar contexts. It could have been otherwise. Some hypothetical language could have every synonym appearing in radically different sentence types. English doesn't, neither do most human languages. Why do human languages have this property? Cognitive economy. If dog and puppy refer to related concepts, we tend to talk about them in related situations. We feed them, we walk them, we complain when they chew the couch. So the words appear near the same context words. Bow, leash, couch. That's not a hidden law of language. It's a fact about how our minds carve up the world and how we chat about it. Which means the hypothesis has predictions. It should fail on cases where similar concepts get talked about in different situations. and it should succeed on cases where different concepts get talked about in the same situation. Both of these happen, and that's what the counterexamples are about, which brings us to beat 3. Beat 3, the big counterexample. Antonyms. Hot and cold are opposites, but they appear in almost identical contexts. The coffee is hot. The coffee is cold. Same sentence template, same neighbor words, drink, water, room, day. If you feed a word-to-vec model a big enough corpus, hot and cold end up right next to each other in embedding space, which means the model can't tell them apart on meaning. It knows they're both temperature words. That's it. Other counterexamples. Homophones. Bank the riverbank and bank the money place. Same word, different meanings. Word2vec gives one vector. It gets averaged into gibberish. Function words like the and of appear literally everywhere. Their embedding tells you almost nothing. Rare technical terms. Not enough context to learn from. All places where the hypothesis strains. So why does the hypothesis dorky despite these failure modes? Because the failures are localized. Antonyms and function words are a tiny fraction of the vocabulary. Most content words, nouns, verbs, adjectives that carry real semantic weight, obey the hypothesis, which is enough to power search engines, translation systems, retrieval-augmented generation. The failure modes are edge cases. The main effect is real and strong. That's why Firth's throwaway line changed the world. 3 takeaways before the quiz. 1. Harris 1954, Firth 1957. Same idea, different sentences. Meaning can be recovered from co-occurrence. That is the whole distributional hypothesis. 2. It's an empirical claim about human language use, not a law of physics. Human languages happen to have this property because of cognitive economy. 3. Counterexamples exist. Antonyms, homophones, function words, but they're a small fraction of vocabulary. The main effect is strong enough to power search, translation, and LLMs. Quiz 1. Who actually said, "You shall know a word by the company it keeps," and when? A. Chomsky 1957, B. J.R. Firth 1957, C. Zellig Harris 1954, or D. Mikolov 2013? B. Firth 1957. The same year as Chomsky's syntactic structures. The two men were arguing opposite sides. Harris said essentially the same thing in 1954, but with less flair. Firth gets the credit because slogans travel. Quiz 2. What kind of claim is the distributional hypothesis? A mathematical theorem. B. An empirical claim about human language use. C. A linguistic universal. Or D. A law of physics. B. Empirical. It could have been otherwise. In some hypothetical language, synonyms might appear in radically different sentence types. Human languages happen to have the property that similar meanings appear in similar contexts because we talk about similar things in similar situations. That's cognitive economy, not necessity. Quiz 3. Why does the hypothesis work despite antonyms having similar contexts? A. It doesn't work. B. The failure modes are localized. Most content words still obey it, which is enough to power NLPC because Firth said so. Or D. Because antonyms don't actually have similar contexts. B. Localized failure. Antonyms and function words are a small fraction of vocabulary. Most nouns, verbs, and adjectives obey the hypothesis strongly. That's enough to build search engines, translators, and LLMs. The failure modes are edge cases we handle separately. That's what the polysemy video is about. Back to the puzzle. Firth, 1957. One sentence. Meaning from usage. Half a century later, that sentence powers word2vec, glove, and every LLM, which raises a practical question. Once you have the vectors, how do you actually compare them? Cosine similarity? Euclidean distance? Jacquard? They give different answers. Next video, which one, when, and why? Next time, similarity measures. Cosine, Jacquard, and Euclidean. Which one search uses? Which one RAG uses? And the 5-line Python function that runs half the internet. Hit subscribe.